Hey everyone, it's Justin again. In this lesson, we're going to be talking about rectangles, which are another type of quadrilateral. I'm sure you've learned about rectangles previously, but this lesson we're going to look at them through a geometry perspective. By the end of this lesson, you will be able to classify rectangles by their properties. First, we will define rectangle. Next, we'll discuss rectangle properties, and then finally we'll complete one practice problem. What is a rectangle? Now, I'm sure you're already familiar with rectangles and you can easily picture something like this. While your idea of a rectangle is probably correct, what we need to remember is that we're looking at rectangles through a geometry perspective now. The definition that matters to us is that a rectangle is a parallelogram whose angles are all right. A rectangle is a parallelogram? Wait a second. Let's think about this. Parallelograms have opposite sides that are parallel. Is that also true for rectangles? Yeah, I guess it is. Oh, okay, that's interesting. So, a rectangle is also a parallelogram. It's just more specific because it has all right angles. Let's start building a visual representation of quadrilaterals that we can keep expanding on throughout this unit. So, we have quadrilaterals, which is the biggest category that includes any polygon with four sides. Parallelograms are a more specific type of quadrilateral because they have to have four sides. Plus, the opposite sides have to be parallel to each other. We could add on rectangles, which are a more specific type of parallelogram because it requires four sides with opposite sides parallel to each other, plus all of the angles are right angles. Notice that my rectangle section is still inside the parallelogram category and the whole quadrilaterals category. Let's investigate what this new, more specific category means for what we know about rectangles. Just to refresh your memory, here are all of the properties of parallelograms. And since rectangles are a more specific type of parallelogram, all of these properties are also true for rectangles. However, having these right angles also gives us additional properties for rectangles. The most obvious one is that all of their angles are right, since this comes right from the definition. The other new property for rectangles is that their diagonals are congruent. So, in the case of our rectangle shown here, that means that TE is congruent to RC. If you'd like to explore this property more, you'll find a challenge exploration in your Notes template PDF that gives you the opportunity to use your proof skills to demonstrate why this is true. All right, now that we have these new properties, what can we do with them? There are three different ways to show that a quadrilateral is a rectangle. The first is if you have a parallelogram with at least one right angle. Once you know it's a parallelogram, having just one right angle is enough to know that all of your angles are right. The second way is if you have a quadrilateral with all four right angles. Notice that this says quadrilateral, so we don't need any additional information besides four sides and four right angles. The last way is if you have a parallelogram with congruent diagonals. All three of these tests work by providing enough information to show that you have a parallelogram with all right angles, just like our rectangle definition requires. I'm not going to go over it all here, but if you're interested in exploring why these three tests show this, there is an extended learning opportunity in your notes. Our practice problem says, determine the best description for BARK, quadrilateral, parallelogram, or rectangle, based on each set of information. We have three sets of information here, so let's look at them one at a time. Set A says BK is congruent to AR, KY is congruent to YA, and BY is congruent to YR. Pause here and take a moment to mark these congruences on your picture. Your picture should now look somewhat like mine, although we may have used different numbers or tick marks for different congruences. This gives me one pair of opposite sides that are congruent. Also, diagonals that bisect each other. Knowing that, Which of the three labels is the best for this set of information? Diagonals that bisect each other is one of our parallelogram tests from the prior lesson. That means that with the information in set A, BARK is a parallelogram. We still haven't used our other piece of given information here. Does having one set of opposite sides congruent allow me to say anything more specific about BARK than that it's a parallelogram? Now, this is just another parallelogram property, and since we already now know that BARK is a parallelogram, that doesn't tell me anything new. So our final answer for set A is just parallelogram. Let's clear everything off of here and look at set B next. Set B says KA is congruent to BR, and the measure of angle RKB is 90 degrees. How could you summarize this information? Since KA and RB are my diagonals, that would mean that I have congruent diagonals. Angle RKB is here in the bottom left, and I've marked it with a square since it's a right angle. I can summarize this by saying I have one right angle. So I know my options here are quadrilateral, parallelogram, or rectangle. Let's think from least to most specific. We know that this has to at least be a quadrilateral because it has four sides. Getting a little more specific would be a parallelogram. Do either of these properties help me say that BARK is a parallelogram? Neither of these properties here satisfy the requirements of any of the parallelogram tests. So no, I can't say that BARK is a parallelogram. That means we're down to either quadrilateral or rectangle. Since all rectangles are parallelograms, this seems like a long shot, but just a few moments ago, we said that there was one special way that we could prove that a quadrilateral is both a rectangle and a parallelogram with just one property. What was that one property that could allow us to do this? Check your notes from earlier if you need to. We could say that a quadrilateral is a rectangle if it has all right angles. Do we have all right angles here? No, we were only given one right angle. So for set B, we cannot say that BARK is a parallelogram or a rectangle. It does have four sides, so that means that quadrilateral is the best description that we can give it. Now let's look at set C. Set C says BA is parallel to RK. BK is parallel to AR, and the measure of angle RKB is 90 degrees. Pause the video here to mark this information on your picture and summarize what information this gives us about BARK. Check your annotations against mine to make sure that yours are conveying the same information. We can summarize this information as both pairs of opposite sides are parallel and we have one right angle. Can you draw any conclusions from this information about whether BARK is a quadrilateral, parallelogram, or rectangle? Maybe you noticed that both pairs of opposite sides being parallel gives us enough to say that BARK is a parallelogram. This is absolutely true because that satisfies the requirements of one of our parallelogram tests. But we can actually take this even further. If you look back at your rectangle tests, one way to show that a quadrilateral is a rectangle is if it is a parallelogram with one right angle. This is because once we know it's a parallelogram, we can use parallelogram properties to show that these other three angles are also right angles. So even though parallelogram is an accurate description for BARK, rectangle is the best one. So, to recap, set A gave us a parallelogram. Set B gave us a quadrilateral because we couldn't prove that it was anything more specific than that. And finally, set C gave us a rectangle. Now you can use properties to classify four-sided polygons as quadrilaterals, parallelograms, and rectangles. You have a few opportunities to push your thinking in your notes template PDF for this lesson, including that activity about proving why the diagonals of a rectangle are congruent. Make sure you look them all over before moving on to the practice game. See you next time! Hey.